So good morning, all of you. This work is something in the direction of using some kind of crowdsource-based data to understand public transport behavior in India. So in yesterday's discussion, we are talking a lot about how to collect the data or how to use the data for understanding transport in Indian cities. So this particular work is something in that direction. So there are basically two outcomes from this work. So we have a paper in short paper in last year's spatial and a full paper in this year's spatial on this particular work. So coming to the problem, so transport is a big problem in India because of multiple reasons. Like you have problem in roads, like these potholes are the bad roads. There are congested routes. Then there are scenes of overcrowding in the buses, which creates a lot of problem for the daily commuters. So when they travel through this kind of public transport. So what we have tried to understand here that by leveraging the crowdsource-based data from the smartphones, can we understand that what are the current scenario and what are the different patterns in this kind of regularities that we can put in a map, which we call some kind of rich map, rich transit map, and that we can use for different kind of purposes, like for the policymakers, for the normal commuters, or for the government to understand what is the basic traffic pattern. So our broad objective is to design a system which generates a rich transit map. By rich transit map, we want to mean that we want to put multiple things on the transit map, like the transit routes, different public bus routes, the bus routes related features like the stoppage, the waiting time at the stoppage, then that crowdedness in individual buses at different stoppage, like if you board a bus in a particular stoppage, what is the probability that you will get a seat. Then we want to find out different kind of road related features like the congested patches, the short turns, and the bumpy roads. So you want to develop a kind of smartphone based app which will intelligently log user data without consuming lots of power from your smartphone. It will automatically sense this kind of route features and the road features and generate the complete trajectory of the bus routes along with those features. So we have some preliminary observation from the collected data. I will go to the data later on. So what we have observed that, well, this kind of features are spatio-temporal in nature. It changes with respect to time as well as with respect to different spaces. And if we consider the public bus route, now if we rely on the crowdsource-based data, it may happen that, well, a particular person may board at point A and he has get down at point B. Now you have to differentiate whether the person has traveled in route 1 or route 2. Now what we have seen that, well, this kind of spatio-temporal features, they vary a lot between these different routes. So we can basically apply some kind of artificial intelligence or machine learning based approach to identify individual routes from this crowdsource based information. So these are basically our broad step. We use a smartphone based application to collect the sensor data. Then we basically identify different kind of point of concerns like this turns, the speed breakers, the bus stoppage, which we called as point of concern, and we store that in the database. Then based on these individual POCs, so we develop the app in an intelligent way, like you do not use the GPS all the time because it takes lots of power. So we only switch on the GPS when we encounter such kind of POC, and from this information we basically use some kind of spatial geometry to find out the complete trajectory. Then once you have these individual trajectories from multiple users, then your task is to combine this individual trajectory, like this is the trajectory from user 1 and this is the trajectory from user 2. You need to identify that those two trajectories belongs to the same bus route. So we apply some kind of learning based method to switch these trajectories to find out the complete bus route. So that is the broad idea. Now for collecting the data, what we have seen that, well, to make the app intelligent, we have from the smartphone we have different kind of sensors, like you have the normal inertial sensors like accelerometer, gyroscope, all these things. Then you have the sound sensors. Now what you can do then, well, using those sensors you can clearly identify the transport mode, like using this acceleration you can identify whether a person is traveling by bus or car. Then even if a person is traveling by bus, then using sound sensor you can clearly identify what type of bus he is traveling to, whether it is a AC bus or a non-AC bus, all these things. Then again, using this sensor information, you can identify different kind of events, like when a person is getting in a bus, while he is in a bus, and while he is coming down from the bus. So we get all these signatures, and then based on these signatures, we see that well for different kind of point of concern, like a speed breaker, turn, potholes, congested route, we have different kind of signatures. You can use that signatures to automatically detect this point of concerns. Once we have that information, from there, we apply some kind of special geometry based approach to identify individual trajectories. So what I have mentioned that well, you do not have the complete GPS data because you do not log the complete GPS data to save energy. We only log the GPS data when we encounter a point of concern. Now, from that intermediate GPS information, we actually basically try to find out what is the complete travel trajectory. Now, once we have that travel trajectory, then we actually combine this travel trajectory. Say this is this blue line is the travel trajectory from one user, and this green line is the travel trajectory from another user. So we combine them to find out the complete trajectory, travel trajectory. And to do that, we need to identify whether they belong to a single bus route or a different bus route. Now, what we observe from our data that well, different bus routes, they actually show different behaviors. Like one bus route, for them the stoppage pattern and the waiting time in individual stoppage, it is different from the stoppage pattern from another bus route. So we basically leverage on this kind of information to find out individual bus routes, and then stitch them to find out the complete route from this crowdsourced data. So actually we are not involving the user. So one of our objective was to not involve the user extensively, like to log that when he is getting onto a bus, when he is coming down from the bus, because that will, if we go for that kind of user intervention, then there may be problem, like the user will not be interested to give that data to us. So our objective was like we will just install an app, it will run as a service, and it will be intelligent enough to detect all these things automatically and generate the complete travel trajectory. Well, so this is our broad system architecture. We have multiple modules, which some of these modules are executed inside the smartphones, and some of the module like this database and the database processing, they run on a particular server. So using this, we have, it is basically like a client server based architecture where the smartphone collects this kind of sensor data, send it to a CityMap server where the data is being processed, all these point of concerns and the trajectories are generated. Then from there we actually find out the complete travel route. So coming to how we have evaluated the system, so we have basically deployed the system in 3 cities in India, Kolkata, Bhubaneswar and Durgapur. So we have actually recruited some 50 volunteers. We have given them some incentives so that they can install the app, carry the app while they are moving, and from there we are collecting the data, and we have found that well, we have got data for some 4 or 5 routes. We have got complete data for some 4 or 5 routes for some nearly 3 years. So we have that data, and we have used that data to do all these kind of analysis. So what we have seen here that well, regarding this route identification based on this artificial intelligence or machine learning based approach, we are doing fairly good. So the average error that we have, it is quite less in case of our approach. And if we compare it with a GPS based kind of architecture, so what we have seen that well, the error is less. At the same time, we consume significantly less energy compared to a kind of GPS based application when you switch on the GPS for all the time, and you get the complete trajectory and use that GPS information, GPS log to generate such kind of travel trajectories. So this graph shows us the impact of data accumulation. So what we have seen that well, if we have some 10 or 20 runs at individual routes, we can do fairly enough to estimate these individual travel trajectories and infer the routes out of that. So in conclusion, basically our objective was to solve one important problem in transport domain, to get the data from crowdsource based approach and then analyze the data to on the fly So we have got some good success, but the problem that we have faced again to deploy the application in a mass scale and to get the data from kind of a huge set of numbers. So the data that we have, it is not really a big data. We have some fair amount of data on which we have done the experiments. So that's all regarding my presentation. So any question? Yeah. Yeah.
So did you label data?
It is not a kind of label data. So what we have done, so during that 3-year span of experiment, initially we have recruited some volunteers, given them some HiSpark so that they can label what are the things. So we use that as a kind of baseline, and from that baseline we infer rest of the things.
So if you're not allowing the GPS to be on continuously, how do you detect where you have POCs or not?
So the thing is that, say for example, consider one POC is like a speed breaker. Now from the accelerometer data, you can find out the speed breaker. Once you are finding out the speed breaker, at that moment we are switching on the GPS, getting the GPS position. But well, there can be some timing drift because of which you can have a little bit of error. So we are applying some method to correct that error as well. Now you have this GPS location for intermediate points. From that intermediate points, we have done some kind of estimation to find out what can be the possible travel trajectory based on some map-based approach using spatial geometry.
All right, next science speaker.
Thank you.